Unit 39, how are we going to deliver this? We're going to deliver it using the online Google Classroom, our virtual classroom. To assist you, you're going to be given a student book, which is online, to complete your work. But however, you can print it off if necessary. And any of your resources that we use will be available on the Google Classroom. We do use third-party programs, so you need to be aware of not just our Google Classroom, but also Kahoot, which deal with quizzes. We also Edpuzzle for watching videos and questioning. And our final and favourite is YouTube, right? Video content. Can't do anything without YouTube these days. The session structure. How are the sessions structured? You'll have a 5-minute exercise, which is a puzzle, a question, something to get your brain ticking over. All right, they're not hard. You then have the learning outcomes explained to you, what's expected. We then go into our session delivery, and this is where you'll use the student workbook to complete activities and take notes. As we've said, this will be supplied to each student. We carry out checks on learning and understanding throughout the day, and we do that through formative assessments. And then finally, a review and a reflective journal, okay, is made. What does it cover? It covers the mechanical principles. We do this over 75 guided learning hours, 60 of which are delivered, 12 hours of self-study. That could be watching a YouTube video at home, or it could be writing your assignments, stuff like that. We have 4 learning outcomes. The first one is engineering science. The second one is engineering maths. The third one is limits and fits. And the fourth and the final one is engineering materials. Going into these in more detail, engineering science, by the end of the learning outcome, students should be able to do: use SI units of measure such as length, mass and time. Describe the effect of heat on metals. You need to be able to state the laws of friction, power and transmissions. List basic electrical principles. And finally, you should be able to construct simple calculations involving heat, the strength of materials, forces, frictions, work and power. Going into engineering maths. Okay, everybody's favourite. Not really. By the end of the learning outcome, students should be able to do, and there is a fair bit. However, the unit's not designed to create mathematicians, all right, but it should allow students to refresh your basic maths and science skills that you learned in high school or on any other engineering unit that you've studied. All right, so you should be able to use fractions and decimals, positive and negative numbers, trigonometry. Should be able to calculate the following: ratios, proportions and percentages, area and perimeter of common planes, volume of common shapes. You should also be able to do the following. You need to solve simple equations by substitution. Solve linear equations, that's just straight lines. Solve simultaneous equations. And the final one, transpose, which just means move from one side to another. Transpose formulae. Nothing difficult. You'll be taking through it step by step. Limits and fits. If you're a machinist, you should be aware of this already. Use the current standard, which is British Standard 4500, to determine the limits of size and type of fit for a given assembly. You should be able to determine the maximum and minimum clearances or interference, right, for holes and shafts that make up assemblies. You need to be able to determine the maximum and minimum metal conditions, and determine the size of the go, no-go elements of a plug caliper gauge. The last one is interpret geometrical tolerances. Better late than never, that one. Engineering materials. By the end of the learning outcome, students should be able to describe the basic structure of materials at an atomic level. If you're using metal, plastics, rubber, carbon fibre, when it all boils down to it, there are atoms, protons, electrons, neutrons, and so on. You should also be able to draw atomic lattices. There are 3 of them in total. You need to be able to state the material properties. Every single material has them: strength, ductility, elasticity, malleability, plasticity, hardness, toughness, so on. The list goes on and on. And then to test them all, we should be able to use Euler's modulus graph. That will measure rate of elasticity, yield points, rate of plasticity, ultimate tensile strength, basically when something breaks. Simples. Your assessment. How are we going to assess everything? As we said, through formative and summative assessments. All right, we make sure that you can achieve the criteria. Your formative assessments, that's done by your instructors, constantly ongoing throughout the session, every session. And then you have summative assessment. These are not set by Walsall College or by your instructor. It's set by EAL, which is the awarding body. You have 2 knowledge-based assessments, summative assessments. These are exam-based. All right, so it covers the first 2 learning outcomes, engineering, maths and science, but then there are questions from the others. You then have 1 practical-based, which is observed and assessed. Okay, a pass grade must be achieved on all 3 of these to achieve the unit, but it is a merit and distinction. Your target grade is merit, so you should be aiming for that. Now, regarding these exams, I'm fully aware that we're in lockdown at the moment and everybody's getting excited. All right, but you will have time to go into the college and carry out the practical elements. Your reflective review happens at the end of the sessions. All right, it's just a short reflective questionnaire, 3 questions. There's 3 parts of the session you liked, 3 parts you didn't like, and if you had to do it again, what would you change? You can't just give me it was rubbish. You need to have a reason why it was rubbish. That's the only way we can improve the sessions. Okay, good luck.